Okay, so let's get started here. We're looking at the idea of maxima and minima today. Finding and completing the square, finding the vertex form from the standard form. If you recall, you can let me know if you have any questions or anything via the YouTube chat, via Remind, via Edsby messages or email. I'll be checking those throughout. So if you have any questions, again, let me know. If there's any issues along the way, let me know. But we're looking at converting the standard form of the quadratic to the vertex form. So we've done a lot of work with the first and last, the vertex and the standard form and the zeros or roots form. We've completed the trinomial here and expanded it out to get to the standard form, and we factored the standard form to get to the factored form, but we have not done this yet, this transition between these two. So we're going to look at that today. So just a quick example of working with this. I'll pick a problem here. And so we have let's try something like this is number 8D. So 8D has this y equals 3x squared minus 24x plus 10. So we're going to look at completing this square here. And so to do that, the first step is always the same. We look at that, we're only concerned with the first two values. We kind of ignore the C value here until the end of everything. So we look at these first two and we factor out the a value. Doesn't matter if it's a common factor or not, but we're going to take out that a value here. So we're going to take this 3 out. And so when we factor that out, we're left with x squared, and then negative 24 divided by 3 would be negative 8x, close the bracket, plus 10. So we're ignoring that part at the end. We just let it kind of hang out there, not do much with it. And so now what we need to do is we're trying to get this x minus h squared portion. So that's a perfect square trinomial. So we're going to create ourselves a perfect square trinomial. And so if you recall, in a perfect square trinomial, when we expand it out, the value here, this middle term of what'll be the perfect square trinomial, it is a it's 2 times the value that we want in our perfect square trinomial. So if we get half of that, negative 4, that's going to be the value. It's going to be x minus 4. So I'm actually going to make note of that. So it's going to be x minus 4 squared. That's what we're looking to get to. So if we want to get to x minus 4 squared, when we expand it out, we're going to get the minus 8x. And the last term is going to be plus 16. I don't want to put the bracket there yet. So that last term is going to be plus 16. So this way we've created our perfect square trinomial, but we cannot just add 16 to the equation and not change it. It has to stay the same. So the only way we can add 16 is if we also take it away. So I'm going to take away 16. And then I have my plus 10 here hanging out at the end. So what I've done is I've just added and subtracted 16. Half of this number squared. So half of 8 squared. Now I'm going to get rid of this minus 16 at the end just to leave the trinomial here. So to do that, I'm going to multiply just the last number by 3. So we still have 3x squared minus 8x plus 16 in the brackets. And then we have 3 times negative 16. It's going to give me negative 48 plus 10. And so what I have there now is a perfect square trinomial and then a couple numbers I can simplify. So y equals 3. And then remember earlier we said that that was what we were looking for, half of that middle value right there. So x minus 4 squared, and then minus negative 48 plus 10 going to give me negative 38. So here I've completed the square. Right? This is what this process here is, completing the square. We've completed the square, and we've went from standard form to vertex form. And in that case, we have now found the vertex of this equation. So the vertex of this is 4 and negative 38. It's a graph that's opening up, so the vertex is going to be a minimum value, and the minimum value is going to be at the negative 38. So this is a graph that might look something, if we were to sketch it out really quick here, just a really rough sketch. Opening up, it's at 4 and negative 38, so maybe way down here. And then we also know another point. So we know the vertex, we know it's opening up, it's rather skinny. And we also know the c value, which is the y-intercept, so it's up here somewhere at 10 maybe is here. And so I have something that might look like this. So this is the 10, this is the 4 and negative 38 point value right there. So there's a quick sketch of that as well. So that's information now we can garner from being able to complete the square. The biggest thing with this is just practicing over and over, remembering this little piece here, this middle step, middle portion here is the most difficult portion I find. Again, you're just taking half of this number and then adding and subtracting the square of it, and then that half number is going to end up being, because we've created that perfect square trinomial. It's always going to be plus minus in that order. The perfect square trinomial is always going to have a plus sign here. This middle sign will vary depending on the situation, plus or minus. It can be either one, but this last number, the third term in that, has to be a positive number. So just looking at some questions here that were assigned with this one. So I had things like 3, 4, 5. Actually, let's take a quick look at 5, just to familiarize ourselves with the graphs and the positioning of them. Again, so switch over to the textbook here. And if we look at number 5, that asks us to match each graph with the appropriate equation. And so as we look at the various graphs, again, the key value here that we're working with is the vertex of the parabola. So it's just the idea here is to be able to find the vertex given any form of the equation that we have. Specifically, we're going from standard, in this case, to vertex form. But again, looking for our vertices, negative 5, or x minus 5 squared plus 1 is going to give us 5 and 1. So that's probably going to be D. So A matches up with D. B here, that's going to give us a positive 1, positive 4. So that's going to be the yellow one, A. And again, the negative sign here, or sorry, the positive sign here means that this is going to be a negative 1. So negative 1 and positive 4, that's going to be our B, our red graph, and then the final one would be C, where we're down at negative 1. And we should be able to pick these graphs out, at least in cases of the blue and teal greeny graph, just by looking at the y values, as the y values are different. Here, the k value, so plus 1, minus 1, should be able to pick it right away. The difference would be picking between these middle two. The negative, again, remembering that the negative goes on the positive side, and the positive moves things over along the negative direction. So just being able to pick out that key value of where we are on the graph is important. And then a couple questions. Let's try a question from number 10. So the earlier questions, they're similar to what we just did, just a little more. Some of them don't have an a value to worry about. Some of them are easily factorable. Some of them are not so as easily factorable, and just kind of builds up. But let's try number 10 here. Number 10, there was a and b I had assigned. So let's try. Let's try 10b. Let's try 10b. So y equals 4x squared plus 24x plus 41. And if I switch over here, back to my notebook. Alright, so here's our equation that we're working with. We need to complete the square in this case again. And so completing the square, we are factoring out that a value. So we're starting with our a value and taking it out of the first two terms. So y equals 4x squared plus 6x, and then the plus 41 is separate at the end. And again, we're ignoring that plus 41 until we're all done making the perfect square trinomial. So next here, we take half of the plus 6, which is going to be 3. So we're looking for an x plus 3. That's going to be the thing we're looking for, so I'm going to write that down here. So half of that is 3. 3 squared is 9, so I'm going to add and subtract 9. 4x squared plus 6x plus 9 minus 9. And again, we're adding first, then subtracting, so that we're not changing the equation by adding, subtracting, and the adding will allow it to be a perfect square trinomial. So I've added and subtracted 9, and then I will multiply that 4 out front by the negative 9 to get it out of the parentheses. So we have 4x squared plus 6x plus 9 in the parentheses. 4 times negative 9 going to give me negative 36 plus 41. And now I can simplify these two pieces. This here is a perfect square trinomial, so we simplify that down to what we created it to be, which is x plus 3 squared. And then negative 36 plus 41 is going to leave me with 5. And so I have a vertex at negative 3, 5. And the rest of the question actually said to find the vertex, sketch the graph, and label the vertex and 2 other points. So we need to find another couple points on here. So I'm going to do a quick sketch of the graph first. And we're looking at a graph that has a positive a value and it's fairly narrow, so we're opening down. Our vertex is at negative 3 and 5, so let's say maybe here. And then because it's opening down, we know there's going to be no x intercepts here, but there is a y-intercept. It's at 41, so that's another point we can mark off somewhere down the line here. And again, this is just a sketch, so we're not going to be perfect with our graphing. So we're going to say that is negative 3 and 5. We're going to say that point is negative... sorry, I messed that up, didn't I? That's a positive graph. It's opening up. So we are going to have x-axis. Actually, let's redraw that graph too so we can kind of fit it better. My mistake. I was thinking I was picking the other question that was going to open up, or open down. Okay, let's redo that. Negative 3 and 5. Now I'm thinking of positive numbers. Positive 5, negative 3. There's my proper graph. So we fix that up a little bit better. There's a point up here at 41, and again, it's still not going to cross the x-axis. So now we need to find ourselves one more point. How do we find another point on the graph, a third point? All we need to do is pick some value and plug it into the equation. So we can pick a number like, I don't know, 2. So we can pick x equals 2. It'll be way over here, but just fitting on this, let's do something that's going to fit maybe on this side. Let's do -4 even. So I could do y equals 4, -4 plus 3 squared plus 5. So I just picked out -4 as a value to try out. And then I will expand that out, find the y value. -4 plus 3 is going to be -1. -1 squared is going to be 1. So now I have 4 times 1, which is 4, plus 5, y equals 9. So when x is -4, y is 9. -4, and then, so this point here could be -4 and 9. And again, this is just a sketch, so it's fairly rough. And scaling is probably not perfect on it, but that would be another point. If I need to find any more points, I could just pick other number x values and sub them in and find their corresponding y values. The last one I want to take a look at here is number 15, I believe, was the other one that the word problem I had signed. Yeah, number 15. So if I switch over here so we can take a look at number 15 quick. Number 15 says the cost in dollars of operating a machine per day is given by the formula C equals 2t squared plus, or minus 84t plus 125, where t is time and hours the machine operates. What is the minimum cost of running the machine? How many hours must the machine run to reach this cost? So if we're thinking about the minimum value of a quadratic, then what we're looking at is the vertex. So what we need to do here is find the vertex. How do we do that? We need to complete the square. And there are some larger numbers here because a lot of times when we assign questions and we're first learning things, we like to start with nice small numbers so you guys can pick up the concepts. But when we actually apply things, a lot of times in the real world situations, they're not going to have nice numbers. You're going to have these complex numbers. You're going to have decimals, fractions, things like that when we're doing real world modeling. But this one here is still a little nice because it has some whole numbers for us to start with anyways. Let's take a look at this. So we're going to complete the square. Again, same process as before. We factor out the a value. So we divide everything in the first two terms by a. Now we take the middle term. We're going to make a perfect square trinomial. We divide this number by 2. So we're looking for a perfect square being t minus 21 squared. So if we were to expand that out, the plus portion would be the 21, negative 21 times negative 21, which is going to give us 441. So we're plus 441 minus 441 plus 1024 at the end, or 1025. And so now we have a perfect square trinomial right here. We can get rid of this negative 441 by multiplying by 2. And when we multiply that by 2, we're going to get 882 plus 1025. And now we can simplify our perfect square trinomial, add these two up, and we will have the value for the vertex. So we already noted that that was going to be what the perfect square trinomial would look like. And then we have the negative 882 plus 1025. And so that gives us 143 in the positive. So our vertex in this case is at 21 and 143. And so it had asked in the question, what was the minimum cost of running the machine? Well, the cost is the y value, so this is the minimum cost. So that's the minimum cost, $143, and it occurs after 21 hours. So that gives us the two values that we need. Now thinking about this in terms of just looking at our numbers, if for some reason you did this and all of a sudden you had a positive number here, well then that would mean the vertex would be at a negative number of hours. That wouldn't make sense. So you can use some common sense when you're doing some of these realistic problems to see if you've done the right thing, especially when it comes to that middle term, making sure that whatever's here at the start, or sorry, whatever's here, it shouldn't necessarily be at the start because you might have a negative you factor out. It stays consistent throughout. It's this last one here, the adding and subtracting. Again, adding, then subtracting. So that is a few examples working with completing the square. I do hope that helps out a little bit for those of you and answer some questions. Again, if you have any other questions in regards to anything else from that section or any other section, shoot me an email, shoot me a message on Remind or Edsby, and I can help take those up with you. This is going to be the last section regarding quadratics as well. So it's going to kind of consolidate everything with a couple big formulas. So make sure you are understanding the various forms of the quadratics, converting between them. The last major concept we cover here is working with the x-intercepts, getting the x-intercepts regardless of whether we can factor or not, and then just solving some problems with them. Okay. Again, if you have any questions, email Edsby, Remind. Otherwise, have a good day.